review again. If I wanted to figure out what is the angle that has a cosine value of negative root 2 over 2, it's got to be a 45 because there's a root 2's in there. And we know that cosine values are found between here and here. It's a 45 because we have 1, 1, and a root 2. And the x value happens to be negative. We okay on that?
Got it.
Good. So now, so we would say that the angle that has a cosine value of negative root 2 over 2 would be what?
180 minus 4. Isn't it? Or you can
Well, my reference is 45, but it would wind up being, remember, going
it would be this 40. 180 minus 4.
So you're at 135, but when we're dealing with what we're going into today, I want it only in radians. So this is 3/4 the way to pi, so it is 3 pi over 4. Yes, sir?
Back to the what's the angle root 2 over 2. Even though it's the other 45, it would still be 45 or?
Because, well, when I place it here, because it's got, we're talking cosine to be negative. I'm at the 45 here, my adjacent's the negative 1. If it was here, it wouldn't be a terminal side. No big deal. This is what we've been working on. Same idea with the root 3 over 3 for the tangent. What angle has a tangent value of root 3 over 3? Well, it's a positive tangent value, which means we're going to be first quadrant. And remember, tangent can be opposite over adjacent. It's going to be your 30 degree because it's going to be 1 over root 3 to get 2. So my angle that has that would be pi over 6.
Oh, so for that one you don't do that. Okay.
Okay.
Did you answer that? I saw you go like, wait, oh. All right. Now, what happens here is that there are going to be more than one angles that will have the tangent value of root 3 over 3. There's another angle that has the cosine value of negative root 2 over 2. What we've been doing is been finding them in a like off a standard position. What I'm going to change this into ever so slightly today is to find all the angles within one revolution that has cosine of negative root 2 over 2, that has the tangent value of root 3 over 3. So we're going to figure out the other angles that have that. It's not that bad, but it's going to be written very slightly different. Instead of it like this, it's going to start out like this. And I'm going to solve for x. 2 times the sine of x minus 1 equals 0. I heard there was.
No, there was like a question where if there were functions and then the functions were multiplied. It was like replace the sign with the function.
Okay.
And then there were 2 of them, and you had to find the intersection of them.
Okay, it's just your calculator.
Yeah, so I just solved it for the function, like
Yeah.
f of x, and then I put them both in, and then
Those are pretty simple. We actually do some intersection style later. So here you wind up with 2 sine of x minus 1 equals 0. And what this means literally, 2 times the sine of some angle minus 1 equals 0. What is that angle? Yeah, we started talking about it as I was alluding to where we were heading. So if I want to get x by itself, do you guys agree add 1 divide by 2?
Yeah.
So the sine of x is 1/2. So that means x would be what angle has the sine of 1/2. See how now it looks like what we've been doing? Good. So we would sit there and plot this.
that equals 30.
Well, hold on. We're going to plot this out. We know that it's at 1 and 2, so we're at a 30. Oops. We know we're at a 30-degree angle. I don't want degrees. I want radians. So that is pi over 6. Now, what's going to be different with the terminology that they're going to ask you to solve an equation is the following statement. where your angle value is between 0, including 0, through 2 pi. What that means is list all the angles that have that sine value that's equal to a half.
Would you do the, whatever, I forget what it's called, the, where you add,
The revolution in?
yeah, like,
Not yet. The 2 pi n stuff, not yet. We're not that. We'll do that on Friday. This is a little bit easier of a concept to understand.
So x would equal pi over 2.
Yeah, there's one angle that has pi over 6, that's 1/2. Pi over 6 has a sine of, that's, where else is sine positive?
The second.
Over here.
Pi.
So what's the angle here? What is this degree measure you speak of? What is it? And 5 pi over 6. Those are the two angles that have the sine value that's equal to a half. That's all it is.
Wait, so you want to make sure you test it.
Yes. And again, what you're looking at here is when you are given this parameter, it's basically asking you to list all the possible angles within one revolution. Yeah.
Isn't one of them, one of the terms for that, right? There's pi over 6, 5 pi over 6.
Yeah.
General.
This is the general solution is when you're tacking on pi values, however many times it takes to get back around to it. That's a little bit more abstract. We'll talk about that on Friday. I don't want to overburden you guys. This is easy.
Yeah.
List all the possible angles within that. So the thing you have to remember here is in your quadrants, positive, positive, negative, positive, negative, negative, and positive, negative.
That's for sine.
or it's negative in the second and fourth. Oh,
Correct. Remember, your ordered pairs go cosine, sine. So cosine's positive in the first, positive in the fourth. Sine is positive in the first and second. Tangent is positive in first and third. That's basically what it looks like. Yes, sir.
What did you do about the third and last one?
What this is telling you to do is list all possible angles between 0 to 2 pi.
Oh, so the good questions will say that?
Yeah. Yep, that's all that means. You're just listing out all the possible angles that have whatever sine value or something.
I just want to remember, how do you find tangent is r over x?
Y over x. Tangent sine over cosine. Yes, ma'am.
So is there only ever going to be 2 angles?
No, sometimes there's 1, sometimes there's 2, sometimes there's 4.
Wait, you don't, how would there be 4?
It was
I
like,
mean, like,
I'll show you. I'll show you. Yes, sir.
Wouldn't there be 4 possible?
No, because the other values here, if it's down in the second, or excuse me, the third quadrant, wouldn't the sine value be negative?
Yeah.
Oh, okay.
That's why.
You don't want negative.
Because it's asking for the positive. All right. Let me show you another one.
oh.
4 times the cosine of x plus 1 equals negative 1. Again, we want to find all values of theta, or our x value here, between 0 and 2 pi. We're going to list all the angles that make this equation work. Shouldn't be very scary to start. Subtract 1, divide by 4.
I swear, I was going to get on that.
That was close.
Are we okay? I got the cosine value of x equal negative 1/2, which means I'm looking for the value, what angle has a cosine of negative 1/2. So you start just like you would start any inverse problem by placing it. Where is cosine negative? Left.
Second and third.
Second and third quadrants. We know it's got to be coming over here. Cosine to be negative 1 over 2 means the adjacent is the negative 1. There's my 2. So what's opposite me? Root 3. Good job. What angle is opposite of root 3 to 36 and 90? 60. So that means my reference angle is 60, which means my
120.
So in terms of radians, I am
2 pi.
perfect. Your reference angle is bounced up off the x-axis, pi over 3, and where else will that be negative? Down to the third quadrant at? Perfect. Because the other value is down here because it's still -1 and a 2. Not bad, is it? The only difference to what you did with the quiz stuff, finding the angle, is that you have to do the algebra to get to it. And it's just asking you to list all of them, as opposed to just being in that standardized quadrants that we look at. Yeah.
Wait, will you have any problems like this on every quiz tomorrow?
No. No, I'm just showing this step further because it's good, because we don't need to sit here and do nothing for another day. Yeah.
So when we find our answer, like here it was 120, 2 pi over 3, we use the angle that it takes to get there.
Yes, cosines in the second quadrant,
Yeah.
you're using that reference. Yeah, it always takes to get there.
And then, okay.
Not that bad, is it? Okay.
Could you draw in the top of the square root?
Maybe. Because the square root button in this doesn't have that.
It's just like the,
Huh? Kind of.
I just haven't noticed it.
Now, we probably did this right away. Do you need to rationalize this?
No.
No. Why?
it's easier this way.
It's easier.
It's easier this way.
Oh, I tried squaring and I never.
What? Did you try like cubing it?
No, don't. Yeah, it's by itself. The reason why I'm saying that you don't need to rationalize this style problem is because it's easier to figure out the triangle that you're in. Tangents opposite over adjacent. So you know that you have a positive value of tangent, so you're in the first quadrant. Your opposite value is 1, your adjacent's √3. What's your angle?
30.
30. So you have a 30-degree angle here, but we don't know what that degree thing is, so it is pi over
6.
Good. What other quadrant is tangent positive? Third. So it is.
Well, I was gonna say 1 pi over 6.
That's 7 pi over 6.
It's the fifth
Perfect.
In the third dimension.
It's in the third quadrant because tangent's positive there at 7 pi over 6. I always love when people think, they look at the ceiling like the answer's there.
Well, it's because like if you look at other things, it kind of distracts you.
It's
Oh,
like when you
height.
get good ideas in the shower. And then just like,
Yeah,
Like when you look up, it's like clear thinking.
because.
Like,
like,
scientists
back
actually
to the back
think
of
it
your
is.
head. I can see clearly
Tests and
now
stuff, if I don't know what to
the
do, I just like
close ceilings.
look at the wall. It usually helps.
I just
All right.
I don't know what to do on a test.
I just said 7 pi over 6. But I don't feel like it's off. Here's it's ahead.
Wait, Mr. Murphy.
Okay, so who cares?
This is the last one.
Are those multiplication or just x?
Okay, yeah, I was making sure I understood the rational, or radius.
Sine of x times the tangent squared of x equals the sine of x.
Wait, what? Wait, so when you divide by
Hold on. Wait. Write it out.
Are you allowed to divide the sine of x?
Write it out.
What do you think?
Yeah.
Aren't you dividing the same thing on both sides with an equal sign? Doesn't it stay balanced?
Yeah.
Well, I was saying, she said, can you just do this? It is tangent squared. What's sine of x divided by sine of x? 1. So you wind up with the tangent squared of x is 1. How do you undo squaring? Square root it. Uh-oh, I did a square root over an equal sign. What should I do?
I keep going, yeah.
Oh, this is how you get 4.
Oh, ew.
Ew, that's so gross.
But you're right.
Wait.
Yes,
You
sir.
are right.
Is
You are
that-
wise.
You wouldn't need to do anything to the x, right? Because you took the square root sign.
The x is built into that tangent square.
X equals the inverse tangent.
4,000.
So x is equal to the inverse tangent of plus or minus 1. You're yelling 45, you're right. So we all agree that at 45 degrees, pi over 4, tangent is positive 1.
That is very true.
Where else is the tangent positive 1?
Third quadrant.
Third quadrant, so it is at 5
Five.
pi over 5. 5 that hidden to it.
So you just like make the,
You just keep adding.
so like it's 1 pi over 4, so you just add 4 pi over 4 to it.
Yeah.
Then you get 7 pi over 4?
In the second quadrant, tangent's negative 1. 3 pi over 4.
All this makes sense.
And then the other quadrant would be at.
7 pi over 4.
So is it possible that you can get 4 solutions?
Yes.
Absolutely.
That's impossible.
You look very worried.
No, I'm not worried at all. I just feel really sick.
Oh, I'm sorry. Yes, please.
See, he's not like Mr. Pepper.
I'll even sign it in pink.
Love this.
That's what it's there for, right? So this shouldn't be scary.
Wait, can you
But it is.
read that? It said it would behoove you?
It would be,
It behooves not to trust teenagers.
It should say it would be confusing.
who wrote that?
I don't know, some teenager.
It would be Hugh View.
It would be.
Because you.
That was Miss Gordon's favorite.
And is it behoove?
It was a better decision.
You walked so fiercely, that was scary.
What?
You look very aggressive.
Oh, okay.
It was like pounding footsteps. I was like.
These are very quiet shoes.
Supposed to be Ian.
It would be beneficial.
Isn't there an Ian Behoove? Like,
There is an
more than
Ian.
one? Oh, I thought that wasn't a save.
Can I go right now?
Oh, you're doing exactly
Just write you, not the word you.
No, I'm gonna write the word you. I'm not a hooligan. Wow, that writing really.
Sorry, I don't know.
3 times the secant squared of x minus 4 is 0. Is everybody okay with the idea that the first thing you're going to do is add 4 to 5x3?
Yeah.
Yeah.
How it works out with guys? It's a thing. It's
Now,
a thing.
here's where the little subtle tricks start to happen. Secant is the inverse of what?
Cosine.
Cosine. So if I take the inverse on one side, what do I have to do the inverse? What do I have to do the other side?
Take the inverse.
So if I inverse both sides, don't I get this?
Right. Wait, what?
Don't worry.
Because the inverse is flip, and the flip of secant is cosine.
Wait, are you
Ding, ding,
required?
ding, 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 ding,
What the
ding.
halfway side?
Do you know?
It's
Oh, so
easier.
you can just.
You can do it the way you did it, and we will work out the same.
Okay.
Sometimes it's easier for people to see it this way. So now, yes, sir.
You could switch, like, you could switch the step you're about to do, the step you just did, right? Because that's what I did. I took the square root of it first, and then I got
Yeah.
secant of x equals 2
Plus or minus. Yeah. Did you do plus minus though?
Or no. Plus or minus 2 over 3, and then 3 over 2.
What's up?
So now you just take the square root of both sides, right?
Yep.
And then it's root 3 over 2, and then
Whoa, 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 whoa.
plus or minus root 3 over 2. Oh my God.
So, what angle has a cosine value of root 3 over 2? So that's what we ask.
Sorry, I was a little excited there.
3. And we were like, 3.
So you place
There
it.
you go.
Thank you. So that's got to be our 30-degree angle. So at pi over 6 has a positive cosine value of root 3 over 2. What is the other positive value of cosine? Positive. What's the other positive angle of cosine? What is it?
7 pi over 6. 11 pi over 6.
11 pi over 6. Because I'm looking for, I was just listening to my positives first. That's all. I mean, all right. In the grand scheme of things, does it matter which ones you put it, order you put them in? No. As long as you have them all, you're okay.
So where were we starting?
Because cosine is positive first and fourth. Cosine is negative second and third.
Oh, I always got tangent.
So you're at 5 pi over 6 and 7 pi over 6.
Tangent is positive first and third and negative second and third.
So you have 4 possible solutions.
Does this work out to be any solution?
No. I'm not going to give you one so you have to use a calculator for it. I mean, you can, but there's no reason. All right, I'm going to give you the hard ones.
You can have all the others also.
Oh, I gotcha. Okay. Okay.
Oh.
That's easy.
Hey.
Now, this may look weird. It's bigger. What I want you to think of is when you have the numbers out in front of a cosine, think of it as a coefficient. Notice how you've got a cosine of x and a cosine of x on both sides. Just pick on the little guy. No. Think of this as 5x minus root 3 equals 3x. What would you do? You would subtract 3x, wouldn't you?
Oh, yeah.
If this was you would subtract the 3x from correct? What changed?
There's 3 extra letters.
There's just that happens to be 3 extra letters. That's about it. If you want to treat it that way, there's just 3 extra letters.
Oh, so we don't have to do any dividing?
No.
Well,
You
do
will eventually, but you move the 3, subtract the 3 cosine x,
And then you get 2 cosine x.
because then I'm going to add that root 3 there, so you get 2 cosine x is root 3.
Okay.
It's so easy, you want to throw your pencil at it, and then look up, and say, holla.
No, plus or minus.
No plus or minus this time, very good.
Breaking.
Didn't we just do a root 3 over 2?
So it's a 30.
So it's pi over 6 and
5 pi over 6.
cosine.
Oh, cosine, 11 pi over 6.
Very good.
Wait, so you. It's positive here.
That's the whole idea.
Cosine is x, so
Yeah.
anywhere where x is positive.
Oh.
Yep.
That's
That's all it
how
is.
I figured it out.
My brother would probably draw some graph in the air.
That's all it is.
Cosine is x.
And tangents is sine.
Oh, wait.
And tangent's sine divided by cosine.
Yeah, it's just with the.
So, but that's what we're looking at, okay?
That's the thing.
What?
The thing, it always bothers me when I show them, I feel like 2 plus 3, 7 plus 2, I kind of figured it out.
What, where?
Wait, where?
You know what I'm talking about? This thing.
What is
Yeah.
it?
It says 2 plus 3 equals 10, 7 plus 2 equals 60, 3 equals 5. I figured it out.
Congratulations.
Wait, and
Oh,
I
it's
do.
multiplying.
Adding.
Oh, it's first number. Wait, can you repeat the question?
It's easy.
All right. 2 plus 3 equals 10.
let me write this down.
Okay.
7 plus 2 equals 63. 6 plus 5 equals 66.
No, I got it.
8 plus 4 equals 96.
I don't get it.
Yeah, I get it.
All right.
Oh, you multiply?
You add them together and then multiply by the first number.
Yeah, so
Okay, why
it would
did
be
it
9
explain?
times 16. So that would be 90 plus 45 plus 9 144.
Oh, see, you didn't say anything. Usually you say, let me give you a few to try out.
Or like do these tonight. Or do these for me.
Yeah, he was his dude.
You have an assignment, try something new.
Ooh, Man City.
That's like too formal for this class.
You
Yeah.
love this one.
These are all problems within one revolution.
Why don't you want us to do those? No, you don't want us to do those.
Okay.
Why didn't you want us to do 36, 37?
36 you have to, I need to show you some other tricks first. 37 is just a calculator problem. You have to hit the buttons on the calculator. It's not placed within one of our triangles. Same thing with 33. So we're just going to do ones that'll. What's nice about this is that it helps you still to find your inverses, but you have to remember that there's a difference between what we did here today and what we were doing. What we were doing is we were finding them within the boundaries of the regulations. Here those regulations are within one revolution, so it's a little different, but it's still the same process, okay? And we'll try it out. Requiz tomorrow, we'll finish going through this stuff on Friday, so